Okay, as promised, here is the recording for notes 4.6. You are welcome to print this document off of Canvas, or of course write down stuff on your own paper. But we're just going to jump right in and try to get it done as quickly as possible. So what we're doing here is we're graphing square roots and cube roots, all right? And so you need to know what the parent function looks like in function form, meaning equation, okay? And that would literally be just the square root of x or just the cube root of x. That's called the parent function. And it's a parent function because there's no transformations. It hasn't been reflected, stretch, shrink, move to the right, left, nothing, okay? Now, for the graph, for the parent function for square root, you have to know, and you can always type it in Desmos, that it's going to have an end point at the origin, and it's going to kind of curve up and to the right, okay? And for the cube root, it's going to have a turning point at the origin, and it's actually going to come, it's going to make like an S-shaped. So we're going to come, it's almost easier to do it in two motions, okay? So we're going to kind of come up and curve towards the origin, and then we're going to go up and to the right, okay? All right, so then we need to talk about how to get the domain and range. All right, so please don't forget that the domain are x values. So you read the graph from left to right, and the range are y values. So you read the graph from bottom to top, okay? So for the domain, all right, we've got our end point. And as we come in from the left, the end point is the first point on the graph that we get to. So that means our domain starts at the end point, and it's the x value. And then we trace our graph to the right forever, so that means it goes to positive infinity. Okay? Now, for the range, we work our way from bottom to top, and so the first point we get as we come up from the bottom is the end point. And so our range is also going to start at the end point, but make sure you use the y value there. And then we decide if it goes up forever or down forever. Well, it goes up to positive infinity. So for our parent function, the domain and range look the same, all right? But the most important part you need to understand from that is that you need to use the end point, okay? Now, the domain and range for a cube root is a little bit easier because it doesn't have an end point. So you don't have to worry about stopping at a specific number or starting at a specific number. What you do have to understand, though, is for the x values for the domain, all right, the left end is an arrow that's pointing to the left forever. So that means you start at negative infinity. And then you work your way to the right, but then you keep going to the right forever. So you go to positive infinity. Okay, and that's going to be the domain for every single cube root function no matter what. And then when I do the same thing for the range, remember you're technically starting at the bottom and working your way up, but this arrow is not only pointing to the left, it is also pointing down. So you actually are still starting at negative infinity, and then you're working your way up. And this arrow, yes, it's pointing to the right, but it's also going up forever. And so the range and the domain here match, all right? But that's because they're both all real numbers, and they will both always be all real numbers, okay? The next thing we talked about was transformations, all right? And that means what does it look like? What does the function look like when we shift the graph, whether it's the turning point or the end point, whether we shift it right, left, up, down, reflect over the x-axis, vertical stretch, or vertical shrink. So instead of using the section here in the middle on the document, what I want to do is I want to go to a blank page, and I want to just draw the formula that everything is based off of. Okay, so f of x equals a times the radical. It doesn't matter if it's a square root, cube root. It actually could be a fourth root, fifth root. Doesn't matter what the root is. The transformations are the same. All right, and so we're gonna do one set of transformations. Okay, now we're gonna do it how we've learned it before. Okay, hopefully this formula looks familiar to you because we did a very similar formula with absolute values and quadratics. Okay, so I'm not going to go in any particular order. Well, I mean, I'm not going to start at the front. I'm just going to kind of pick out what I think are the easier pieces first. Okay, so what you have to remember is if there's addition or subtraction inside the grouping symbol, which in our case would be under the root, all right, that's your right or left shift. Okay, and what you have to remember is that a minus is actually a right shift and a plus is a left shift. Okay, all right, then let's move out here. A plus or minus outside of the grouping symbol is your up or down shift. Plus is up, minus is down. All right, well then let's move back to the front. Hopefully you remember that if there is a negative, okay, that means that you are going to reflect the graph over the x-axis. Okay, so there's not always, that's supposed to be a CT, there's not always a reflect because there's not always a negative, but if there is a negative, the graph will reflect over the x-axis. All right, so then the last one, the last piece that we haven't talked about yet is the A, okay? And the A is what decides if you have a vertical stretch or shrink, okay? And then you have to remember how to know the difference. Okay, well, you're going to have a stretch if the absolute value of A is greater than 1. All right, that means that number multiplied in front is bigger than 1. And you're going to have a shrink if that number is a fraction between 0 and 1. And the reason I have the absolute values around it is because if it were negative, the negative does not affect the stretch or shrink. The negative means reflect over the x-axis. Okay? So now what we're going to do is we're going to look at some examples and actually decide what the transformation is. So I'm going to go back to my page, scroll down past all the stuff we've done, past that. All right, and remember you're comparing these to the parent function, all right? And but it doesn't matter what the parent function is, the transformations work the same way. So in number 1, a -7 under the radical, that's just like being in the grouping symbol, is a right 7, and the +2 out of the radical is an up 2, okay? Now, if you think you got the hang of it and you want to pause the video and try the other ones on your own, that would be awesome. All right, otherwise we're going to keep on rolling through. All right, number 2, it doesn't matter that it's a cube root, works the same. The 4 is multiplied in front. It is bigger than 1, so that is a vertical stretch. And then the -1, you have to look very carefully. The radical is not, the radical is not extended over that -1, okay? So that is actually a down 1. All right, in number 3, we have a negative in front. So remember that means reflect over x-axis, and don't be lazy, you gotta write it out, all right? And then we have a +3 under the radical. That means it's inside the grouping symbol. So that's a left 3. And then for the last one, we have a 1/2 multiplied in front. So that's a vertical shrink. Then we have a -2 under the grouping symbol. So that's right 2. And then we have a -6 out of the grouping symbol at the end. So that's a down 6. All right, so remember you could have lots and lots of transformations in the same problem. All right, well now we're going to take it one step further, and I am going to give you a description of the transformations, and I want you to turn it into a function. All right, so if you're going to turn it into a function, you need to know that you're going to write f of x equals. All right, that's what makes it a function. Okay, then when you read the description, it's going to tell you whether you should be using a square root or a cube root. Now, you should obviously pick that piece out, but leave yourself a little bit of space here in the front in case you need a negative or in case you need a number because there was a reflection or a vertical stretch or shrink. So I'm going to leave myself a little bit of space there as I read the problem. It says the square root parent function. So leave myself some space, draw a square root. Obviously, I have to put an x underneath it. Okay, that's what makes it the parent function. It's reflected across the x-axis. So remember, if you have to tell me it's a reflection, it's because there was a negative in front. Okay? All right, then we keep reading. Then it is shifted 7 units to the left. Well, remember, a right and left shift goes under the radical, so you might need to extend your radical. And left is actually a plus. All right, so maybe I'll make this one look a little bit better and extend that. All right, and then last but not least, 1 unit down. So remember, that goes after the radical, and down is a minus. So those are the 3 transformations described, and so that is the function that goes with it. All right, in number 6, it tells me that it's a cube root function. And all it tells me is that it has a turning point located at -2, 3. Okay, well that is actually telling me something about my transformation. If I start at the origin and I go -2 and then up 3, okay, that's my turning point, but I went left 2 and up 3. So that's also my transformation. All right, so sorry, I do need an x under that cube root. All right, left 2 would put a +2 under the grouping symbol, and up 3 would put a +3 after the grouping symbol. And then it still didn't say anything about vertical stretch or shrink, so I don't need any numbers in front, and it was not a reflection, so I don't need a negative, so I'm done. Okay? So there will be a couple of those for you to practice on the homework. All right, and then we need to finish up our graphing. All right, and so we're going to start with square root. So they should all look very similar to the square root parent function. Please take advantage of Desmos if you're having trouble drawing the graph. Okay, if you're having trouble drawing the graph, take advantage of Desmos. Type it in Desmos, see what it looks like. You can even click on the end point and the turning point, all right? But for square roots, what you need to know is that it definitely has an end point, not a turning point. So if you're just copying stuff on your paper, don't even write the word turning point. You need to write the word end point, okay? Now, if you're not going to use Desmos, you can use your transformation to help you find that end point. The transformation is up 5. So if I literally go from the origin up 5, that will be my end point. And that ordered pair is 0, 5. And then I just have to remember, if it's positive, it's going to look exactly like my parent function, which goes up and to the right. If it is negative, all right, which we're going to see in a minute, that's going to reflect down. So it's going to go down and to the right. All right, now everything else is just reading the graph. All right, so we've got our endpoint. All right, so we need our domain. Remember, the domain are the x's from left to right. And as I come across the graph from the left, the first point I get to is the end point. And so I'm starting at the x value of the end point. And then I have to decide if my graph is going to point right or left. Well, I hope it's going to the right, right? Because if it was pointing to the left, I would not have started at 0. Right? So that's going to go to positive infinity. Because again, we're going to the right. All right, then when I do the range, remember you're working from bottom to top. So as you come up, the first point you get to is the end point again, but you need the y value of the end point. And then you need to decide if the graph, where the graph is going, up or down, and it's going up. So up is positive infinity. Okay? So there's my domain and range. Now we need to do end behavior. Okay, well, I don't know about you, but when I look at this graph, I see a point on one end and an arrow on the other end. Well, if there's a point, that means one of your end behaviors needs to use the point, okay? So on your paper, I hope you're copying the whole sentence, as x. The arrow stands for the word approaches. Well, the x value of the endpoint is 0. F of x is the same thing as y. So then what is the y approaching? Well, that's the y value of the endpoint. So you need to make sure that you actually write that sentence out. Okay, you can't just put the numbers 0 and 5. All right, but for the other end, it's an arrow. Okay, so remember when you fill in the x stuff, okay, you want to know, is the arrow pointing right or left? If it's pointing left, you would use a negative infinity. If it's pointing right, you would use a positive infinity. Since this arrow is pointing right, we're going to use a positive infinity. All right, then for the y value, or the f of x value, okay, remember you want to look at whether that arrow is pointing down, and you'd use negative infinity, or is it pointing up, and you're going to use positive infinity. So it's the same arrow, but it's not only is it pointing to the right, it's pointing up, so I'm going to use a positive infinity there. Okay? All right, now when you do the increasing or decreasing intervals, what you need to know is that you're only going to have one or the other. You can't have both on these graphs, on either one or the other. Okay, and so once you decide if the graph is increasing or decreasing, you can just write the word none on the other line, or I guess you could just cross it out. But please, if you're writing everything out on your own paper, you need to actually write, you know, none next to that word. Like, don't skip it completely. Okay, so remember with increasing and decreasing, you're looking at x values. So you're reading the graph, read the graph from left to right. Okay, so we're going to start on the far left. Whoops, come on. All right, here's the leftmost point, and then I trace it with my finger, and I notice that it's increasing. Okay, so right away, I'm going to say none for decreasing. Okay, and then all you really need to know is that if it's increasing, you can copy the domain. Okay, since it's only doing the one thing and I'm using x values, it has to be increasing over the entire domain, so they should match. Okay, so match the domain. Okay. If for some reason it was decreasing only, then that would also match the domain. It would just be on the decreasing line. All right, so again, if you're writing this on your own paper and you're doing these problems later for homework, I need you to show me both increasing and decreasing, and then you would literally write none next to one of them and then an answer next to the other one. Okay, so please don't leave off the one that that doesn't have anything. Okay, so I just want to make sure we do that. All right, now I did not do all these problems in class, nor am I going to do them in the video. All right, because if they're positive square roots, they all look very similar. All right, so I'm going to do a negative square root so that you can see what it looks like when the graph gets reflected. Okay, so what I'm going to do, again, you can use Desmos if you want. All right, but I'm going to use my transformations to help me. So I know this thing gets reflected over the x-axis, which means it's going to get flipped down. All right, the -2 means I'm going to go to the right 2, and the +3 means I'm going to go up 3. So my end point is going to go right 2 and up 3, and so it's going to be at 2, 3. All right, that's kind of sloppy. All right. Now, because it is reflected over the x-axis, instead of going up and to the right, all right, it's going to flip down and go down and to the right. All right, so all the square roots that we're going to graph on homework and stuff is always going to go to the right. It's just a matter of going to up and to the right or down and to the right. All right, so there's my graph. All right, my endpoint's 2, 3. And so again, when I do my domain, I'm working from left to right. But the first place I get to is my endpoint, and it has an x value of 2. And even though it's going down, it is still going to the right forever. Now, because when you traced it, you noticed it was going down, you can actually jump down here and say, okay, well, this thing's not increasing, it's only decreasing, and I know that that has to be the same thing as my domain. And then you're already halfway done. Okay? All right, then for your range, you have to be a little more careful on this one. So remember, you work your way up from the bottom. Well, as you work your way up from the bottom, the first part of the graph you get to is the arrow that's actually pointing down. So that means your range starts at -infinity and then works its way up to the end point. And make sure you use the y value of the end point. Okay? So if there's a reflection, it definitely changes the range. All right, it's also going to change your end behavior a little bit. Now, one end is still the end point. So fill that one in, put the 2 next to the x and the 3 next to the y, and you're done with that end. But the other end, you have to pay more attention to. So remember, for the x, you want to know, is that arrow going right or left? Well, this arrow is definitely pointing to the right, so I'm going to use a positive infinity. Then for the y, or the f of x line, I want to know if this arrow is pointing up or down. Well, we said it was decreasing, so it better be pointing down, so that one goes to -infinity. So that is another piece that changes when you have a reflection over the x-axis. All right, and then I want to run through 2 cube root problems real quick, one positive and one negative. All right, so I'm going to do exactly the same thing that I did for square roots, except it's not an end point, it's a turning point. So like, you can go ahead and mark those things out, or only write turning point on your paper. All right, and I'm going to use the transformations to help me. So this transformation would actually be left 3, up 2. Again, if you're not sure, type it in Desmos. A little gray dot should show up on the turning point that you can click on. All right, so if I go left 3 and up 2, I'm actually at the ordered pair -3, 2. So that's my turning point. And then as long as I'm not doing a reflection, I need to look exactly like the parent function. So I tend to need to draw this in 2 pieces. So I'm going to go up and to the right on one side, down and to the left on the other, so that it looks something like an S. Okay? And then for my domain and range, because we have arrows pointing left and right forever, and then technically we have arrows pointing down and up forever, and everything is smooth in between. I don't have to stop anywhere. I can just do negative infinity to positive infinity, and I'm done. Okay? Now, I'm going to skip end behavior for a second because I think the intervals of increasing and decreasing are a little bit easier. Again, start on the left and trace the graph. It's either going to be always increasing or always decreasing, but you have to go from left to right. So this one is increasing only. So we're going to say none for decreasing. And then just like before, you just copy the domain. Copy the domain. Okay, so now let's go back to end behavior. This time we have arrows on both ends. So we're going to have to use only infinities and negative infinities for our end behavior. Okay, so remember you need one left and one right. So for the x, left is negative infinity and right is positive infinity. But then for the y, you need to tell me if that end is going up or down. Okay, so I look over here at the left end, and I hope you can tell that that thing is going down. All right, and then I look at the right end, and hopefully you can tell that that one is going up, so that gets positive infinity. Now, you don't have to write the words when you do it on your paper. I'm just writing them to help you remember what's what. Okay? All right. And last but not least, let's do a negative. All right, so on this one, my transformations are reflect over x-axis, vertical stretch, which is actually really hard to show on a graph this small, but then there's no other transformation. There's no right or left, there's no up or down, so that means the turning point has not moved. It is still at 0, 0. Okay? All right, now, if it was not a reflection, this side would go up and to the right, and this side would go down and to the left. But because it is a reflection, everything is going to flip backwards. So it's going to look like this. Okay? And again, take advantage of Desmos if you're not sure. Okay? Literally type your function in Desmos to get an idea of what it looks like. Now with the vertical stretch, I guess technically I could have made it a little taller, but again, it's just a sketch, and as long as it's got the right shape to it, you'll be fine. Okay? Now, the domain and range has not changed. This thing is still going from the left to the right forever. And in this case, it's actually going from positive infinity to negative infinity. But remember, you read the graph from bottom to top, so technically we should have started down here and work our way up. So we still start at negative infinity and go to positive infinity. All right, so notice the domain and range is the same whether you reflect or not. Okay, the end behavior. Well, we still have a left and a right. So that's the x values, left and right. Then we have to look at the ends and see if they're going up or down. Okay, well, the left end is pointing up this time, and the right end is pointing down this time. So those did switch when we reflected over the x-axis. The other thing that changed when we reflected over the x-axis is when we trace this thing, it's decreasing the entire time. So again, you put none on the increasing line, and then you're decreasing from negative infinity to positive infinity. Okay? And so now you have one of everything, okay, for notes 4.6. Remember, the homework for this is a document in Canvas that you either need to print out and write on, or write on your own paper and take photos and submit. Homework 4.5 is in ALEKS, you need to show your work on your own paper and submit photos for that one as well. And I'll see you next time.